Hey everyone, welcome. I am so excited to have you here today. We are jumping right into a super fast, high-energy masterclass explainer of Chapter 12, Earth, Moon, and the Sun. Look, I know exams are right around the corner and you've got a mountain of material to get through. So the whole goal of this explainer is to get you completely, 100% prepared really fast. We're going to lock in those core concepts, clear up any of that lingering confusion, and get you ready to absolutely crush this chapter on your test. Let's get right into it.
So, have you ever stopped to wonder why the sun always rises in the east and sets in the west? Seriously, it happens every single day, right like clockwork. But why? Is the sun actually physically traveling across our sky? Well, to unlock the secret of how our planet moves and answer this, we need to talk about a really cool concept called apparent motion.
Think about it like this. If you've ever been on a merry-go-round at a park, you already know exactly how this feels. When you sit on it and start spinning, say, to the left or anti-clockwise, what happens to all the trees and buildings around you? They look like they're spinning to the right. They look like they're moving in the exact opposite direction. That right there is apparent motion. The trees aren't actually moving at all. You are. And guess what? The exact same thing happens with the Earth and the Sun.
Okay, here's our game plan for today. We're going to cover the Earth's rotation, revolution, and the seasons, solar and lunar eclipses, do a quick key terms and recap, and then finish up with some top exam tips.
Let's kick things off with Section 1, the Earth's rotation, spinning through day and night.
Now, to get a handle on the Earth, we kind of have to understand how everyday things spin first. Picture a spinning top or even a basketball spinning on someone's finger. What's really fascinating here is to imagine an invisible dotted line going straight down through the absolute middle of both of those objects. That imaginary central line, that's called an axis. Whenever all parts of an object move in circles around a line like that, we say the object is rotating on its axis.
So let's bring that idea right over to our planet. Imagine a line connecting the North Pole straight down to the South Pole. That is the Earth's axis of rotation. But here is the absolute most crucial thing you need to remember for your exams. Seriously, highlight this in your brain. The Earth spins from west to east. It takes about 24 hours to do one full spin. And because we're spinning west to east, the sun, just like those trees outside the merry-go-round, appears to move in the opposite direction. That is exactly why it rises in the east and sets in the west.
And you know, this isn't some brand new discovery. Check out this incredible quote from the ancient Indian astronomer Aryabhata. He used a boat analogy to describe apparent motion, and it's just brilliant. He realized that just as stationary things on a riverbank seem to zoom backward when you're in a moving boat, the completely stationary stars seem to move westward across the sky simply because the Earth is spinning eastward underneath them. Teachers love testing historical context, so definitely keep Aryabhata's observation in your back pocket. Moving right along to Section 2, Revolution and the Seasons, a year-long journey. Okay, I literally want you to take a mental snapshot of this because it is pure exam gold. Examiners are obsessed with testing if you know the difference between these two words. Rotation is just the Earth spinning on its axis. Takes 24 hours, gives us day and night, done. Revolution, on the other hand, is the Earth physically traveling in its massive orbit around the Sun. That takes a whole year, about 365 days, and that is what's responsible for the changing seasons. Do not mix those two up.
So why exactly does this yearly trip give us seasons? Well, it boils down to a super simple equation. Tilted axis plus revolution equals seasons. You see, the Earth's axis isn't perfectly straight up and down. It's got a slight tilt to it. As the Earth revolves around the Sun over the course of a year, there are times when the northern hemisphere is tilted leaning towards the Sun, soaking up more direct, intense sunlight. Hello, summer! 6 months later, it's leaned away, getting spread out, weaker light, and that means winter.
All right, let's dive into Section 3, solar and lunar eclipses, cosmic shadows.
Honestly, eclipses sound complicated, but they're basically just massive cosmic shadows. That's it. It happens when these celestial bodies line up perfectly. Think about the sequence for a solar eclipse. It goes sun, then moon, then Earth. The moon gets right in between the sun and the Earth, casting a shadow down on us. But wait, you might be thinking, the sun is humongous. How on earth can the tiny little moon block it? Well, it's all about something called apparent size. Imagine closing one eye and holding your thumb up to block out a friend standing all the way across the room. Your thumb is tiny, but because it's so close to your eye, it easily covers a much larger object far away. The moon is doing the exact same thing to the sun.
Now, here's a classic exam trap, and I don't want you falling for it. You absolutely have to know which celestial body is the one doing the blocking. In a solar eclipse, the moon is the middleman, blocking the sun from reaching Earth. But in a lunar eclipse, the Earth is in the middle, blocking the sun's light from reaching the moon, which makes the moon fall into shadow. The easiest trick? Just memorize the middleman. Moon in the middle, solar eclipse. Earth in the middle, lunar eclipse.
Time for Section 4, Key Terms and Recap. It is flashcard time. Let's get these definitions locked down.
First up, axis of rotation. This is an imaginary line passing through an object around which all its parts move in circles. Memorize this exact phrasing, guys. When they ask for the definition on a test, this is verbatim what they are looking for.
Next, apparent size. This is the size of an object as seen by the eye, and it depends on two things: its actual physical size and its distance from the observer. Just remember our thumb blocking the friend analogy. That is apparent size in action.
Okay, solar eclipse. This occurs when the moon is in the path of the sun as seen from Earth, blocking sunlight. Keep it short, punchy, and accurate. The moon is the blocker.
And to contrast that directly, we have the lunar eclipse. It occurs when the Earth comes between the sun and the moon, blocking sunlight from reaching the moon. In this case, Earth is the middleman casting the shadow.
Awesome! Now let's do a super quick rapid-fire recap of everything we discovered in a nutshell. Ready? The Earth rotates west to east every 24 hours, and that gives us day and night. This rotation causes apparent motion, making the sun and stars look like they're rising in the east. While it's spinning, the Earth also revolves around the sun once a year. Combine that yearly trip with the Earth's tilted axis, and boom, we get seasons. Finally, eclipses are just shadows. Solar eclipse, moon blocks the sun. Lunar eclipse, Earth blocks the moon. Literally, if you know the points here, you practically know the whole chapter.
Finally, Section 5, Top Exam Tips. Avoid the traps.
Okay, grab your mental highlighters because these are highly actionable tips. Number 1, always remember rotation is west to east. Test makers love trying to trick you with east to west. Don't fall for it. Number 2, never confuse rotation, which is the daily spin, with revolution, which is the yearly orbit. Number 3, when you get an eclipse question, before you write a single word, just scribble a tiny diagram on your rough paper. Sun, moon, Earth for solar. It'll completely save you from making a silly mistake under pressure. And lastly, definitely drop Aryabhata's name and his boat analogy into your answers to snag those extra historical context points.
Before we wrap up this explainer, I'm going to leave you with a bit of a brain teaser to test out your new knowledge. Think about this for a second. If the Earth's axis wasn't tilted at all, like if it was perfectly straight up and down, what would happen to the seasons where you live right now? Take a minute to really think about that. Maybe debate it with a friend. Because honestly, if you can reason through that, you are completely ready to ace this chapter. You've got this. Thanks so much for joining me, and happy studying.